Thank you so much for the introduction. I'm third year PhD student in electronic engineering at the Center for Ocean Energy Research. So if you want to find out about our research group, if you just search COER news, you'll find the members, our publications, and everything that we are trying to do. So our aim is to absorb energy from ocean waves, which is one part of renewable energies. This renewable energy source at the moment is not commercialized, and it's in research stage because it's not economically viable. So we are just trying to model the devices to increase the efficiency, so it will be economically viable. So the devices which capture energy from ocean waves are called wave energy converters. They are loads of different types. So one type, a specific type, is point absorber. This device, as you can see, is a floating structure, and with the movement of the water near to the surface, it moves, and then there is a power take-off system which converts the mechanical energy to the electricity. As I said, lots of research is going on, and with usage of optimal control strategy, we want to increase the efficiency of the devices. Most of the controllers are based on the model of the device, but one problem is that the models that we build for VEX are not exact, and they contain uncertainty, because it's a very complicated system with interaction of different systems, so we don't have the exact models, and then our controllers don't work very good. So my thesis is to estimate the uncertainty of the devices and to design a controller that can deal with this uncertainty. There are two ways that we can work on this. Either we should have a physical experimental setup to do our experiments and tests, or either investigate numerically. I'm working numerically, so I designed the buoy and a wave tank, and considering the experiment type, I'm designing a different numerical wave tanks, and I performed the experiments. Until now, I've done synthesis about the input signal to see how I can build a model where the uncertainty will be low, so I'll have a less conservative controller. Also, the selection of a sensible nominal model is important, and based on the different nominals model that we choose, the efficiency of the control will be affected. These are some results that I've recently published in a journal paper. When we know the model exactly and we design a controller, this is the ideal performance where you see this, and the level of the energy that we can extract is this. But normally, in normal situation that we don't know exactly the system, our energy is less. Based on the nominal model selection and uncertainty estimation and designing the robust controller, I was able to move from this worst case scenario toward the ideal performance. So I was able to increase the efficiency. And the conclusion is that for controller design of VEX, selecting a representative nominal model and specifying the uncertainty bound as small as possible gives less conservative control performance. Thank you.